A good application based question. I want you guys to pause, think over. Let's do it in two parts. One is first try to attempt drawing a diagram, and from that try to write a statement, a given, something like that. Till then, you guys try till that point, and then unpause and check what you guys have written and what I have written, and pause that you will be doing the calculation. Okay, so let's do this in two parts. So till the given part, till a diagram and writing a statement, all of that, till that point you guys can write your own thoughts. Please do till that point. For this question, it's good to start off with the diagram. So let's consider a scenario something like this. So what is that we are looking at? We are looking at two objects of mass m and small m, and the distance between them is small d. Okay, this is case 1. Why am I doing case wise? See, the thing is, they're told if this was an initial scenario, right, compare it with what happens if something, in this case that something is distance reducing, right? So draw one more diagram which would look something like this, but there are some difference. What is the difference that you guys have to figure out, and draw the diagram again. I hope you guys are trying, people who didn't get. So the diagram will reduce to this. What happened? The mass is not changing. This will remain capital M, and this will small m. This will remain small m. The distance between them, it got reduced by half. I'll take this as 2x, and in this case d will be equal to x. Make sense? This is 2x and this is x. So we have to compare, I guess. Let's read the question. How does the force of gravity between two objects change when the distance between them is reduced to half? So we have to compare. So what is that we have to compare? Compare the change in gravitational pull. Okay, so let's begin with a statement. Let's consider two objects of mass capital M and small m. Let the distance d be equal to 2x meters. So it's given that distance is reduced by half. New distance is equal to d by 2. New distance is equal to d by 2. We can call this as d dash. So this will be equal to 2x by x, that is x meters. This is good enough, right? So this is all you are given. Now what we have to do? We have to do the working part. So what does the working begin with? The working begins with stating from a universal law of gravity. So what does the law tell? It tells that the force between any two objects, gravitational pull between any two objects, is equal to this. So for case 1, so we have for C1, F is equal to, we can take it as F1. So I'm talking about this as F1 and this as F2. So F1 is equal to G into M by 2x the whole square, right? So this would be equal to G M by 4x square. All good. Then for case 2, we have F2, which is G M by what? Here d is x square, right? As simple as this. Now we need to compare. So from 1 and 2, what do we have? Okay, if not, we'll just take F2 by F1. So that would be equal to what? G M by x square getting divided by F1. What is F1, guys? G M by 4x square. Always understand 2x the whole square. Any whole square, you need to square the number and the variable. People miss that out and that's messy. That's not right. Okay, the next step would be to remove the division symbol by taking the multiplication symbol. This is 4x square by g capital M and small m, and we have all of this getting cancelled, x squared getting cancelled, 4 by 1. What does it mean? f2 by f1 is 4 by 1. That means f2 is 4 times f1, and your final statement will be what? Very important to write this. On reducing the distance between the objects by half, the force between them increased by 4 times. On reducing the distance by half, the force increased, a gravitational pull increased by 4 times. Okay, so here we have 4 times the force that is exerted between these two in comparison to this. Okay guys, so this is your answer. So please understand, or please try to keep this in mind. First thing is d, I took it as 2x. Why? Since we are reducing by half, 2x by 2 will be a lot simpler calculation than taking it as x and this becoming x by 2. You got it? So such thing is where you guys have to be smart about. So if they had asked like one of the mass is reduced by half, I would have taken this as 2x. Right? Use variables. Don't change m, and d. Let them be that. But take something like d to be 2x. Let the distance d be 2x. Right? So this is how you should figure it out. This is the way forward. Many people find such questions difficult. The main thing over here is taking the variables that is changing as another variable. Like if they are talking about if the distance is reduced by 6 times, cut down by half and half and half, so on and so forth, something like that. Right? So that time you take appropriate value like 8x, something like that. If the distance is doubled, then it's okay. X will become 2x over here. So you need to be smart about what variables to take, when to take. That's what you have to learn. Everything else is simple substitution, and after that it's simple division. You can see clearly there's no much calculation post this thing. If you are smart about this, such questions becomes very easy. Okay, so please pause and copy the answer. And when you guys are copying, try to answer most of the things on your own. Just don't copy it directly from the screen. When you get confused, you can have a look at the screen.